Hi everybody, I hope all of you are doing great. In today's lecture, we are going to continue the dynamic programming series and we are going to solve some problems relating strings, right? So the first problem we are going to see in this section of strings is called palindromic substrings, right? So what the problem is saying, given a string S, return the number of palindromic substrings in it, right? A string is palindrome, we'll see what is a palindrome and we of course know what is a substring, right? Let us understand this question on the board itself and then move forward with the approach. So before looking at the test case I've taken here, let us understand what is a palindrome, right? So any string, right? Any string, for example, A, B, B, A. If you read this string from left to right, that is A, B, B, A. When you read this string from right to left, that is also A, B, B, A. Let's take another example. For example, N, A, M, A, N, Naman, right? If you read this string from left to right, that is palindrome. If you read this string from right to left, it is also a palindrome, right? So like this is the, you can say, thing we are having, and of course shout out to Naman, one of my very close friends, right? So this is the palindromic substring we are having. Of course I can also give another definition of what do we call palindrome. When I reverse this particular string NAMAN, like this string is equal to the reversed form of the string as well, and this is called a palindrome, right? You have to tell me, I'll give you a string, you have to tell me how many substrings of that strings are palindrome. What is a substring, you may ask? So for example, N, that is a substring. AMA is a substring, and can you see this particular substring, this contiguous chunk of this string AMA is also a palindrome, right? So definitely you can see that what we understand by substring, I hope it is clear, and what do we mean by a palindromic substring, I hope this is also clear, right? So any contiguous segment of a string is a substring itself, right? So let us analyze this very interesting test case I have drawn here. So I have drawn this test case here, and let us analyze that what all substrings are palindrome. You can see A is a substring. This is a palindrome, right? Single letter is always a palindrome, right? If you read this from this side or if you read this from this angle, that will be a palindrome only, right? AB. Is this a substring? Yes, this is a substring, but is this a palindrome? No, it is not a palindrome. ABB. ABB. This is also not a palindrome. Okay. ABBA. ABBA. You can see that this is not only a substring, but it's also a palindromic substring, right? You can read from this side, you can read from this side, it will sound the same, right? The alphabets will be in the same order itself, right? A, B, B, A, B, A, B, B, A, B. This is a substring, but it's not a palindrome. Let's move forward. Then if you include Q, then it's never, like, it's not going to be a palindrome itself. This particular substring is also not a palindrome. This particular substring is also not a palindrome. This particular substring is also not a palindrome. Let's start with this B. Single B is a palindrome, of course. Double B, BB is also a palindrome. Now you can see, right, if you take any example, right, BBA, BBAB, not a palindrome. BBABP, BBABP, Q, and so on, that you will not get another palindrome starting from this B. Let's look at this B. So B, single B is a palindrome. BA is not a palindromic substring, right? BAB is a substring, but it is a palindrome as well. So BAB I can write here. And rest of the things you will not be able to find any palindrome. If I take this single A is a palindrome. I have already counted a single A, but this was this A, right? This was this particular substring. I will count this A again because it is a different substring, right? So this A, and you can see this A will not be able to form any other palindromic substring. Starting from this B, single B is a palindrome, but you can see that it will not be able to form any other palindrome in the future. P, single P is a palindrome, okay. PQ is not a palindrome. PQQ is not a palindrome. PQQP is a palindrome. So PQQP, it is also a palindrome. Okay, I hope this is clear. All right, let's move forward. Q, single Q is a palindrome. QQ, of course, two Qs are a palindrome. QQP is not a palindrome. Single Q is a palindrome. QP is not a palindrome. Single P is a palindrome. So can you see how many palindromic substrings are formed here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are total 14 palindromic substrings in this particular test case. I hope the problem statement is clear to everybody. Let us move on to the approach part of this problem and let's get right into it. So before getting into the approach of the overall problem, I wanted to discuss the sub-problem as to how can you check whether a string is a palindrome or not using recursion, right? So how will I do this? For example, A, B, B, A I'm having, right? ABBA. For example, this string I'm having, right? I think it's a very big example. Let's take this example, NAMAN, right? So let's say this is the example I'm having. So if I want to tell whether this whole string is a palindrome or not, I only have access to the end characters. You can see these two characters are equal. Yes, both of them are equal. And can I say if the characters at the end are equal and the string between is a palindrome? Can you see if the end characters are equal and the string in between is also a palindrome, can I say that whole string will be a palindrome? Take any example. For example, ABA. Is this a palindrome? Yes, it's a palindrome. It's a palindrome. If I add the same characters outside the string, like on the other ends, on either the ends, you can see it is a palindrome as well. So what did we derive? That if the end characters are equal and the middle substring is a palindrome, I can simply say that the whole string will be palindrome. I hope this point is clear to everybody. So can you see in this particular exercise the end, you can say ends are equal. Okay. Now since ends are equal, my sub problem is what? I want to check whether AMA is palindrome, right? This is not sure. I'm not sure whether AMA is a palindrome or not, right? I know that ends are equal, but I still want to know whether AMA is palindrome or not in order to, you can say, finalize my answer. Let's look at this AMA. Now you can see here the ends are equal, but we are not sure that whether M, like the string between these two ends is equal, like, is a palindrome or not. I'll reduce my problem to M only. And can I say that single character is always a palindrome? Yes, single character is always a palindrome. From here, I'll return true. Since both of the end characters are equal and the middle string is a palindrome because of this true, I will say that this string is also a palindrome. Since end characters are equal to each other and the string between is a palindrome, I will say that yes, this overall string is also a palindrome. I hope it is clear. How do we check whether a string is palindrome or not recursively? Now what I'm going to write, I'm going to write a code, right? I'm going to write a code in which we will try to generate different palindromes, right? Basically, I'll try to generate all the substrings, correct? And for every substring, I'm going to try whether this particular, you can say using this particular method, whether that substring is a palindrome or not. If that is a palindrome, I'll increment my count, and if that's not a palindrome, I'll not increment my count, right? I'll repeat the approach. I will write a code which will generate all the substrings. I hope you know how to generate all the substrings, right? That is an n square code, right? So I'll write this code to generate all the substrings, and for every substring, what I'm going to do, I'm basically going to check whether that substring is a palindrome or not using this method, correct? So let me write the pseudocode and then it will be more clear. So let us write the pseudocode. So in the pseudocode, of course, like for example, we are having a function main, right? And from this function, I'm going to do what? I'm going to generate all the substrings. So how do we generate all the substrings? For I is equal to 0, I less than, you can say n, which is the length of the string, I plus plus, j will start from, for j will start from I, j less than n, j plus plus, correct? So a substring is starting from I ending on j, correct? I hope this is clear that how we are actually generating the substrings itself, right? So what do we want to do? If you have doubts in what is a substring, what is a subsequence, and what is a subset, you can definitely ask me in the comment section. I can of course make a video on that as well, right? And we'll discuss how to make how to get the total substrings, how to get the total subsequence, all that stuff we can of course discuss on this channel. You can of course tell me in the comment section if this code is not clear to you, right? So this is a code, simple code to generate all the substrings, right? If I generate all the substrings, a substring will be starting on 0, ending on, you can say, an ith index, right? On a jth index, right? And so on, like I will be incremented. I is the starting point of the substring, j is the ending point of the substring. And I want to know what? I want to know that boolean is palindrome. I'll call my recursive function. I'll pass the string here and I'll pass the starting and ending point of this palindrome. I'll pass the string here and I'll pass the starting and ending point of this palindrome. If is palindrome, if this particular, you can say, substring is palindrome, I will increment my count. I want to calculate the count of total palindromic substrings. Now I'm generating all the substrings, and if that substring is a palindrome, I'll increment my count. Now let us see how we're going to implement this recur function which we talked about here. So function recur, correct? S will be passed, the starting point will be passed, and the ending point of the palindrome will be passed to me, correct? So if, like for example, the base case would be what? If starting point is equal to ending point. Correct. Starting point is equal to ending. I am simply going to return true. Why? Because of course, string only containing one character. This is the example of string only containing one character, because that will be the starting point, that will be the ending point. If this is the only character, I'll return true in that case, right? If you can say starting point becomes greater than ending point, this means that I'm having nothing in my, you can say, string itself, right? So I'll return true from here as well, because empty string I can consider it to be palindrome, right? So let's look at this. Full focus. Dekho. If the s of starting point, the character at the starting point, is not equal to the character at the ending point, can I say I'll not be able to form any palindrome? Full focus ka dekhna hai. A, B, B, C, A. So can you see that if this particular string, if these two are equal, yes, check whether the middle string is a palindrome or not. Can you see these two are not equal? And if these two are not equal, I cannot form my palindrome, my friend. I cannot form my palindrome. I'll simply return false from here. So if this is the case, I'll return false. I think that it would not be visible. I'd view this here. So you can see I want to check this particular string. I want to check this particular string. And if I want to check whether this particular string is palindrome or not, I'm doing what? I'm saying that these two characters are equal. Yes, they are equal. So call for the middle string, the string which is between this particular area. BBC will be called, and you can see the end characters are not equal. And if the end characters are not equal, how can this string be a palindrome? Right. So I'll return false from here directly. I'll false from here directly, and this will also return false from here. Right. So return false in this case. Else I'm going to return what? I'm going to return recur for check whether starting point plus 1 comma ending point minus 1, this particular string is a palindrome or not. Is this clear to everybody? So this was the starting point here, this was the ending point here, right? What did we check in the next step? If the ending point characters are equal, can you see this B is on SP plus 1? Can you see this C is on EP minus 1? Correct. And so on. Every time I'm going to pass this starting point plus 1, EP minus 1, I'm just shrinking my, you can say, string, and I'm going like getting like this starting point and ending point close to each other, so that I'm only traversing on the middle strings, right? I hope this particular pseudocode is clear to everybody. Let us quickly write this recursive code and check if this works. So here I'm in the code itself, and what we are going to do here, I'll simply say that, I'll take a count variable is equal to 0 initially. I'll take a n, which is s dot length, which is the length of the string I'm having. I'll generate all the substrings. So how do I do that? For integer I is equal to 0, I less than n, I plus plus. For integer j is equal to I, j less than n, j plus plus. Now I have generated the substring which is starting on ith index, ending at the jth index. All right. What do I want to do next? If you can say I'll take a boolean is palindrome is equal to, I'll pass the string as it is. I'll pass starting point of this substring, I'll pass the ending point of this substring, so that from this string I can access, you can say, the substring part, right? I've passed the starting point and ending point. Now I am having the faith on the recursion that it will tell whether the string between I and j inclusive is a palindrome or not. If is palindrome, if this particular substring is a palindrome, I'll increment the count. Now let's write this recur function. For this recursion function, public boolean recur, string s will be passed, int I will be passed, or you can say string starting point, integer ending point of this particular substring is passed, right? If sp is equal to ep, this means that we are having only one character, return true in this case. If sp is greater than ep, right? If this means that we are having no characters in the string, I'll return true from here as well, right? This is to handle even length cases. You can of course try running this function on an even length string, and you can of course check this particular case out, right? So all right, I hope this is clear, right? Okay, so what do we want to do? If you can see, if s dot char at sp is not equal to s dot char at ep, I'll simply return what? I'll simply return false, that the string is not palindrome. It's not going to be a palindrome, right? And the rest of, like, if both the characters are equal, I just want to return whatever answer the middle string returns. Recur for s comma sp plus 1 ep minus 1. of course, you can see that there are two conditions for a string to be a palindrome. End character should be equal and the middle string should be a palindrome. If end characters are equal, that condition is handled. The answer only depends on this particular thing. Now, this particular function call will tell me is the middle string palindrome or not. And if there's a palindrome, I'll simply return true. If that's not a palindrome, I'll simply return false. Whatever this returns, I'll return simply that only, right? So I hope this is clear to everybody. In the end, I'm going to return the count, and this is the recursive code for this whole problem, palindromic substring, right? Let's try to run the code. It's getting accepted, and of course you can try submitting it, but I think that it will give you a TLE. Of course, constraints are, you can say, somewhat, I would say, low, right? 1000 is not a very big number, but yeah, still you can of course try it out. I'll try to optimize this. We can of course optimize this particular code using memoization. You can see this recursive function can be optimized to memoization, right? And of course we will be doing overlapping subproblems again and again. So I'll call for memoization now, and I'll show you on the board. Let me show you on the board at what this overlapping subproblems look like. Now, to see the overlapping subproblems, just look at this example. For example, this is the string I'm having. First of all, I'll try only A, right? Only A. That will be a palindrome, right? That will be a palindrome. I'll store two here. I'll of course write indexes here. So if starting point is 0, ending point is also 0, 0, 0, answer is true, right? I'm not drawing the whole recursive diagram, but you can of course imagine 0, 0 answer is true. Let's try this substring out, A comma B. Answer is going to be false. 0 comma 1 will give you false answer. 0 comma 2 will also give you an answer which is false. But when you try to find out 0 comma 2, try to find out 0 comma 2, can you see? You can say you will not be calling for the middle thing, right? You will not be calling for the middle thing, and you will directly say that 0 comma 2 will be false. Okay. A, B, B, A. Now this example is very important. 0 comma 3. You can see the 0th character is equal to the third character. 0 comma 3 will be calling for SP plus 1, EP minus 1, right? So 1 comma 2. Is this clear? We are trying to get whether this particular string is a palindrome or not, right? And of course 1 comma 2, both the end characters are equal. I'll simply pass SP plus 1, EP minus 1. SP will become 2, EP will become 1. You can see SP is greater than EP. We are going to return true from here. That in this, because of this case, because of this, you can say even number of characters, I am taking this case, right? So true I'll return from here. 1 comma 2, this is going to return whatever the future returns. I'll return true. 0 comma 3, A was equal to A, and I'll return true from here as well. Now just by doing this, you are having answer not only for 0 comma 3, you're having answer for 1 comma 2 as well. You're having answer for 2 comma 1. 2 comma 1 is not going to happen. This case is not going to happen, but you're of course having a case for 1 comma 2. Now since you're trying all the substrings, can you see when you will try this substring out, you don't have to recalculate this again, right? Right now I was looking for the answer for this substring, whether this substring is palindrome or not. And since this substring is, you can say, a palindrome, and I'm only able to say that it's a palindrome because this particular string is also a palindrome. I've calculated this B comma B already, right? 1 comma 2 I've already calculated. When I'll try to calculate, you can say explicitly for B, like 1 comma 2, because I'm trying every substring, I'll already be having the answer for this. So this is the overlapping, you can say, subproblems, and here we can optimize our approach by remembering the answers for a particular starting point and ending point. Let us quickly write the memoization for the previous code and then move forward. So to convert this recursive code to memoization code, I'll simply write this here again, just like we do always. Wherever I'm calling recursion and call it memo, and I'll pass a DP array here. How many dimensions it will be having? It will be having 2 dimensions because you can say 2 variables are changing, right? So 2 dimensions DP, right? Okay. I've taken it of integer because of a reason, right? In this DP array, if there is a 0, like I'll just write here, if DP of SP comma EP is equal to 1, this means that we have already calculated and the answer is true for that particular starting point and ending point. If DP of SP comma EP is equal to 0, this means that we have not calculated the answer for this particular, you can say, subproblem. If DP of SP comma EP is equal to -1, this means that the answer is false, correct? And if you are not able to understand what is memoization, what is all this stuff, yeah, this is a series which you are going through, right? This is of course, you can say, a lecture, a part of a whole like big playlist which is covering whole DP concepts, right? So there we have used these short tricks to convert recursion to memoization to tabulation, and so on, right? So this is DP comma SP comma IP. If it's not clear that what is memoization, you can of course watch the whole you can say playlist. If you don't want to watch the whole playlist, you can of course watch the first lecture of the playlist at least, where I explain all these important concepts, right? So Memoization, I've changed the like you can say name of this. DP area I've passed here, so wherever I'm calling this function, I'll pass DP here as well. And if DP of SP, comma EP is not equal to 0, this means that we have calculated the result and simply we will return DP of SP, comma EP equal to 1. If this DP, comma SP is equal to 1, I'll return true. Else it's -1, I'll return false. Correct. So whatever this boolean result like evaluates to, whatever this evaluates to, I'll return that only, right? So I hope this syntax is pretty clear to everybody. You should of course get like start getting exposed to, you can say some complicated, I would not say complicated, but you can say some direct kind of syntax, right? So I've just written here DP of SP, comma IP, something like this here. I can also do this, right? If DP of SP, comma IP equal to 1, then return true, else return false, right? Why to do that when this is also a boolean expression? This is a conditional operator. No, it will calculate the same thing in true or false result. It will only give me the result in true or false only, right? So I hope this is clear to everybody. Let us move forward and let us try to remember the solution. So here, like recall and remember, we have done the recall part. Remember part is DP of SP, comma IP is equal to whatever this memoization result is, right? I'm going to return this only, right? And but one thing is there. So if this memoization part is true, I'll store 1 here, else I'll store -1 in the DP array, because DP array we are storing 0, 1 or -1, right? I'll return from here as well DP of SP, comma EP is equal to 1. Whether it is 1, this means that it's true. When it's -1, we are going to return false. I hope this is clear. From here, instead of calling recur, I'll call memo. I'll pass DP here. Let's create the DP array as well. Integer array DP is going to be integer n, comma n. And yeah, it will be initialized with all values 0 in it. So I hope this is clear to everybody how we have converted recursion to memoization. And let's run the code and see if it's working. It's getting accepted. Let's try to submit this. And yeah, it's getting submitted as well, right? So I hope this is clear, the memoization part of this. Now I'm going to take you through the tabulation approach for this problem. This is the interesting part of this problem. And in the tabulation approach, I'm going to use the gap strategy, which we saw in the yesterday's video, right? So let us quickly look at the tabulation part using the gap strategy, and now you'll be exposed to a new form of, you can say, tabulation, right? So let us get right into it. So now according to the gap strategy, I have taken this DP array. This is a boolean DP array, right? This time the DP array is boolean, right? And what I'm going to store in this particular region, in this particular box, is the substring starting on 1 ending on 4. Starting on 1 ending on 4. Is this a palindrome or not? True or false? Of course that's a false. I'm going to store a false here, right? I hope this is clear to everybody. We are going to go according to the gap strategy. So I'll only fill this half of the DP. I'll only fill this half of the DP, and you will understand why am I filling this half of the DP, right? So let's start with the DP itself. So 0 till 0, right? Is 0 starting point, 0 ending point. Is this single character a palindrome? Yes, it is a palindrome. 1 to 1. Is this single character? These all are the starting points. These all are the ending points. I'll just write here as well SP. These are all the EP, right? So starting on 1, ending on 1. Is this particular single character a palindrome? Yes. 2 to 2. Single characters are always palindrome. 3 to 3. Palindrome. 4 to 4. Palindrome. 5 to 5. Palindrome. 6 to 6. Palindrome. 7 to 7. Palindrome. 8 to 8. Palindrome. I have filled the first diagonal. I hope this is clear. I hope you have watched the video of gap strategy. I have filled the first diagonal according to the fact that, of course, single character is always a palindrome. Okay. I hope this is clear. Let's move forward. Let's start filling this diagonal. 0 to 1. 0 to 1. Is this a palindrome or not? Now, 0 to 1. You can see this particular diagonal represents all the substrings which are of length 2. Yes or no? This particular diagonal represents all the substrings which are of length 2. And if I am having a length 2 string, I can only determine whether it's palindrome or not if the first character is equal to the second character. Is the 0th character equal to 1th character? No. I'll write here false. Is the 1th character equal to 2th character for this particular thing? 1th character equal to 2th character? You can see yes, 1th character is equal to the 2th character. I'm going to write true here, right? Because it's of length 2. The palindrome is of length 2, right? Okay. So, alright, let's move forward. 2th character, 2 to 3, like it's 2th character equal to the 3rd character, right? Alright. So 2th character is equal to the 3rd character, is not equal to the 3rd character. I'm going to write a false here. Is 3rd character equal to the 4th character? 3rd character is not equal to the 4th character. I'm going to write a false here. Is 4th character equal to the 5th character? 4th character is not equal to the 5th character. I'm going to write a false here. Is 5th character equal to the 6th character? No, I'm going to write a false here. Is 6th character equal to the 7th character for this particular area? Is 6th character equal to the 7th character? Yes, it's equal to the 7th character. I'm going to write true here. Is 7th character equal to 8th character? No, Q is not equal to P. I'll write false here. So I hope these two base cases kind of things are clear to you, that if I'm only considering the first diagonal, if I'm on the first diagonal, everything will be true on the first diagonal. The only people, like in the second diagonal, if I'm having both the same thing on starting point and ending point, then I'll write true here, else I'll write false, correct? So this was the case when I was considering only of length 1. This was the case when I was considering the string only of length 2. Now let us talk about the generic scenario, right? When the length of the palindrome is greater, the substring is greater than 2, right? So let us look at the substring which starts from 0, ends at 2. So a substring which starts from 0, ends at second character is this particular substring ABB. Can you see that the 0th character is actually not equal to the 2th character? If the end characters are not equal, I'll simply write false here without asking any questions. Is this clear? If the end characters are not equal, I'll directly write false. 0 to 3. Sorry, 1 index to 3rd index. You can see the end characters are not equal. 1th character is not equal to the 3rd character. I can directly write false here. I'll directly write without any asking any questions. I'll write false. 2 to 3, 2 to 4, sorry, 2 to 4, this particular area. I am going to write, you can see 2 to 4. So 2 to 4 is B to B, right? B is equal to B, but is the middle string palindrome or not? 2 to 4 is equal. 2. You can see, I'll draw here. 2. Index 2 and 4 is equal. Index 2 asks what? It asks the middle one. So 2 plus 1, 4 minus 1. 3 to 3. We are going to ask here. This represents whether the string between the endpoints is a palindrome or not. SP plus 1, EP minus 1, my friends. This is 2, 4. 2 second and 4th character are equal. Now we have to ask whether the between string, the string between the endpoints is a palindrome or not. It is written true here. So I'll write it true here. Right. So I hope the algorithm is clear to everybody. If the endpoints are not equal, I'm going to write false right away. If the endpoints are equal, I am going to consult SP plus 1 EP minus 1th index, and I'm to check whether that the middle substring is a palindrome or not. If that is a substring, I'm going to write true here, else I'm going to write a false here, right? So let's look at this 3, 5, 3, 5. You can see 3rd character is not equal to 5th character. I'm going to directly write here a false. False. Look at this particular thing. 4 to 6. 4 to 6. B is not equal to Q. I'll directly write here false. 5 to 7. 5 to 7. P is not equal to Q. I'm directly going to write false. 6 to 8. 6 to 8. Right. I'm going to write here false. Correct. Okay. I hope this much is clear to everybody, that till here I've written only false, 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 false. Whatever was there, I've directly written false here. Correct. Okay. Okay. 0 to 3. 0 to 3rd index. You can see A and A are equal, right? Endpoints are equal. Now I am going to check SP plus 1, EP minus 1. This particular diagonal. SP plus 1, EP. This was the EP minus 1. I'm going to check this particular thing. So I am going to consult this. So is my middle string BB is of course a palindrome, right? This 2 represents that 1 to 2 is a palindrome or not. Of course 1 to 2 is a palindrome. Middle thing is a palindrome. So can you see that we don't have to recalculate for 1 to 2. I can directly write true here. 1 to 4. 1 to 4. You can see B and B are equal. B and B are equal. But look at this particular thing. SP plus 1, EP minus 1. The middle string is not a palindrome. BA is not a palindrome. I'll simply write false here. I hope you are able to get what we are trying to, how we are trying to achieve this. It is a very magical, you can say, stuff, right? It is a very beautiful, you can say, explanation to this as well. And I hope you're enjoying the lecture itself, right? So 2 to 5. 2 to 5. I'll of course speed up a little bit. B and Q are not equal. I'll simply write false here. 3 to 6. 3 to 6. A and Q are not equal. I'll write false here. 4 to 7. 4 to 7. B and Q are not equal. I'll directly write false here. Now 5 to 8. 5 to 8. P and P are equal. If P and P are equal, is the middle substring palindrome or not? SP plus 1, EP minus 1. 6 to 7. I have to check 6 to 7. 6 to 7 is a palindrome. So I am going to write here true as well. That this 5 to 8 is also a palindrome if the end points are equal and the outermost, you can middle, you can say strings are a palindrome itself, right? So I hope this is clear. Let's speed it up. So 0 to 4, of course 0 to 0 is not equal to 4. I'll write false here. Now 1 to 5, 1 to 5, it's not equal. I'll write false here. 2 to 6, 2 to 6 not equal. I'm going to write false here. 3 to 7, 3 to 7, I'm going to write false here. And 4 to 8 as well, I'm going to write false. Correct. I think in the rest of all the cases, I'm going to have false only. So, okay. I think I'm going to have false in the rest of the cases. So, 0 to 5, not equal, false. Right. 1 to 6, 1 to 6, not equal, false. 2 to 7, 2 to 7, not equal, false. 3 to 8, not equal, false. 0 to 6, 0 to 6, not equal, false. 1 to 7, not equal, false. 2 to 8, not equal, false. 0 to 7, not equal, false. 1 to 8, not equal, false. 8 like 0 to 8, not equal, false. And this is how, without recalculating the substrings, I am able to get all the palindromic substrings here itself. Now I just have to count the number of trues. I'm not filling this area. This area will only be having false because these all are the invalid starting point and ending point. How can starting point be greater than ending point, right? So these all cases are invalid kind of cases. So in this type of DP, we only fill the upper half of the DP, and these all actually are the number of substrings I'm having, right? Which is having starting point and ending point, right? So I'll simply count number of trues in this matrix, and the count of number of trues will be the total number of, you can say, palindrome itself. 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. Yes, of course this string was having 14 palindromes we saw in the description. Let's quickly write the code for this and then wind up the video itself. So here we are on the code itself. I'll of course reset the code because we are going to write the tabulation code completely for this. So boolean, I'll of course take n is equal to s dot length, and boolean 2D array dp is equal to new boolean, and we are going to have n and n cross n. We have made this kind of matrix, right? Now I'm simply going to apply the gap strategy. For integer, gap is equal to 0, gap less than n, gap plus plus. Correct. For every gap, right, starting point, integer starting point will always start from 0. I always starts from 0, and ending point starts from the gap itself, right? I hope this point is clear to everybody. You can see here that you can say starting points are always starting on the 0th one, but ending point for this particular thing 0, 4, 0, 5, whatever the gap is, that is the ending point. So EP is equal to the gap, EP is less than n, SP plus plus and EP plus plus. I hope this gap strategy is clear to everybody. We discussed this in the last lecture itself. It is a very short video. If it's not clear, you can of course watch that video. In that video, we learned how to traverse diagonally on a matrix, right? Just like we did in the iteration of this code, right? So that is done. Now what I want to do is, if of course you can say gap is 0. If gap is 0, this means that the substring is having only one character. I'll simply write dp of sp comma ep is equal to true, right? Else if gap is equal to 1, if gap is equal to 1, this means that two characters are there, and two characters, the string which is having two characters is a palindrome if both the characters are equal, right? That is only the case. So dp of sp comma ep is equal to s dot char at sp equal to s dot char at ep. If this condition is true, true will be stored in this. If this condition is false, false will be stored in this. Now for the rest of the cases, I simply want to do what? I'll simply say that, I'll only, of course, calculate the result if, right, for the gaps which is not 0 or 1, gap which is greater than 2, for example, the substring which are having greater than 2 length. If s dot char at sp is equal to s dot char at ep, right? If this is the case, only then, right, I can directly write here dp of sp comma ep is equal to, if this is the case, only then I can of course write a question mark, or let me just look at if statement. So if this is the case, only then I'll write dp of sp comma ep is equal to dp of sp plus 1 comma ep if ep minus sp plus 1 ep minus 1. This is the answer I'm taking for the middle. Okay, end characters are equal, so ask the between substring, the substring between the endpoints, whether that is a palindrome or not. If that is a palindrome, I am a palindrome. If that's not a palindrome, I'm not a palindrome, right? I hope this is clear to everybody. Now, we are only thing remaining is I'll of course integer take a count variable and I'll iterate over this array for integer I is equal to 0, I less than, you can say n, or yeah, and then I plus plus, right? And for integer j is equal to 0, j less than n, j plus plus, right? You can of course start j from I as well. You can of course count here as well. I'm trying to make this code as simple as possible. So that's why I have to write the complete code. You can of course optimize this and get rid of this loop. You can only complete the code in this loop as well, but I will do it like this way because all of the students are not compatible that way. I'll increment the if dp of I comma j is equal to true. I'll simply say count plus plus, else I'm going to return, you can say count itself, right? After counting all the true values in the DP itself, right? Of course, you don't need to write this equal to true as well here, right? That is also one thing, observation, right? And let's run the code and let's see if it's working. Of course, it is working and this code is working just fine, right? I hope this is clear to everybody. I hope this problem is clear to everybody, palindromic substrings. So I hope you enjoyed this lecture of palindromic substrings. We are getting so close to 500 subscribers. Please ask your friends to subscribe to this channel and I hope you all are enjoying the content. Of course, more video lectures are coming in. We have to cover a lot of the questions, and in the starting of the, you can say, the series, I told you that we are going to have 50 videos. Now now the videos are increasing, like you can say, like now I'm estimating about 52 to 53 videos, right? But yeah, I want to complete DP from complete scratch. I want to make you an expert in dynamic programming. You'll just look at the problem and you'll be able to write the dynamic programming code for this problem, right? So I hope this is clear to everybody. I hope you're enjoying the content. If you're doing so, please support the channel. Ask your friends to subscribe. Again, we are getting close to 500 subscribers. It would be great if we reach the, you can say, halfway mark to 1,000, right? That would be a great thing, right? So thanks a lot everybody for tuning in this video. Until the next video drops, bye.